Okay, so in this video, I'm going to assume you have some STL files that contain a series of parts whose goal is to ultimately be milled out of a flat sheet of stock using a CNC router and then assembled by hand or however. So what we can see here is I've made one such part using OpenSCAD. This is simply a rack for holding some vials, and we would need to export it as an STL file, which I've already done. We'll do it again anyways. And then we go ahead and open up FreeCAD. We'll go ahead and create a new one. And we'll save this as an assembly for today. Replace that. Excellent. So let's go ahead and import that file. Excellent. First thing we're going to want to do is make the stock that we're going to be cutting this out of, since we're ultimately going to be placing this onto that stock. So to start, let's go to part design, create a body, create a sketch, XY plane, hit OK. You can see what that did is made a body and a sketch, which we're currently working on. If we click section view, it gets rid of the 3D upper view of the rest of it, so we can just start here. What we want to do is simply make a rectangle, control, start at the origin, have it be some size, close it somewhere else. You can see it has a bunch of constraints on these being parallel, since it's a rectangle, and it being locked to the origin. That's not absolutely necessary, but probably worth doing. So then the next constraint we're going to offer is width. STL files are unitless. There's just numbers. They get imported as millimeters. However, that's designed in inches, so this is ultimately going to be a 24-inch by 12-inch sheet of plastic this will be cut out of. But for now, we simply understand that 24 millimeters is equivalent. So we set that. We set the vertical to 12. So that's nice and good. And then still under part design, we hit pad. We're using a 0.25, a quarter-inch thick piece of plastic. So there we have that. Excellent. So then we need to return to our rack, and we'll go into the arch workbench. Sometimes has to think about. Under utilities, we'll go to split mesh. So now we have a bunch of these mesh files. And also under arch, we'll then go mesh to shape. And that should leave us with some nice solid pieces. Excellent. It just so happens that this lower rack and the upper rack are unique, but the base and the upright and the bases are mirrors of one another. So we actually only need to save one of those. We'll simply import them twice. All right, excellent. Let's go ahead and then export all of these. So then we're going to File, Export, having selected our stock. I already have this out here, but we'll go ahead and overwrite it. That saves it as an external part. This is the lower rack. We'll export that. Put that into a folder, typically. This is the SLE rack folder. I've already done this, but we're going to save over them since we've updated those parts since we last did this a few minutes ago. So this is the, refresh, that's the lower. Overwrite that. Here's the upper. Overwrite that. That's the upright. Overwrite that. And that's the base. Excellent. Those have all been exported. Beautiful. I actually have two parts that I'd like to work with. So there's that and this 8mm vial rack as well. So we're going to go ahead and do the same thing to those with an arch, split mesh, select all that, arch, mesh to shape. Same deal, top and bottom are unique. These two sides are mirrors, so we only need to export one of those. Export under vial rack. That's the upper. That's the lower. Export. This may seem tedious, it's because it is, but the thing that we're going to use to orient these onto our cutting surface requires that these be exported as individual parts. So that's what we're going to do. And here's the upright. All right, excellent. Delete all of those, close this, go back to our assembly. Now, while we're in our assembly, we're then going to use the A2+ add-on. This is the only non-default workbench we need to work with. So that can be installed by going to Add-on Manager and simply searching for it. We have it filtered for what's been installed, but you can find it. It's easy to install. So then we simply need to import all of those parts. So we get our stock. Excellent. Under rack, one of the bases. Remember, there's two bases. Lower, upper, upright, upright. Since I have two separate sort of assemblies that I want to work with, right? This, what I'm calling SLE rack, and then also our vial rack. It can be useful just to group these. And then we can rename that. I just hit F2 to open that dialog, to open it for editing. And we'll call this SLE tube rack. So then we'll go ahead and keep importing things, which is lower, upper, and then there's the two uprights. I suppose you could always just copy and paste that as well. So let's go ahead and do the same thing. Call that vial rack. All right, so now we have everything on here. Now we simply need to start placing them onto our stock. It's important, the way that this works is you basically set up a series of rules that are then enforced by the software for the orientation of things relative to one another. So what's important is that you need something to start with. So it needs at least one thing needs to have a fixed position so that when you start attaching things, everything is relative to that. Our stock here does have a fixed position because we started with it fixed to the origin. But it's important that at least one thing have a fixed position. You can actually just edit that. So once we've done that, we can see this is kind of cluttered at the moment. So one thing we may want to do, and I would say the software can crash. It's good to save every so often. Is if we select one of those whole racks and hit transform, hold down shift, quite sure. But anyways, those are moved now. Still figuring out this software. But okay, so at this point, let's start laying things flat. So we will choose this flat surface and that flat surface and click this Add Plane Coincident Constraint, which will cause them to be on the same plane. One thing that can be useful, since things are going to be placed into our stock at the moment, is we go to our stock and go to Appearance. Let's go ahead and give that, make it mostly transparent so we can see through it. So then we simply want to start arranging things. And what we should do is select that and that. Now, we don't want our parts to necessarily be on the very edge. We'd like for there to be some overhang. And I would say from the edge, 0.5 inches. Or 0.25 inches in all directions is good. So now we can see that this and this are offset by 1/4 inch. And then we want to do the same thing on that plane and this plane. Same deal, 1/4, flip sign. All right, so now that part is placed into our cutting surface exactly 0.25 inches from either side. At that point, now we simply want to continue with our other parts. So let's go ahead and take this and this. And we will go ahead and have this. Have this be coincident with that. And then, importantly, of these two pieces be made a 1/4 inch apart from each other. Now, conveniently, these are on that same plane. So we can just go ahead and use that and that. Make those coincident. Sometimes you might want to have this visible. Figure out how we're going to place everything. Let's choose that edge and that edge. Unselect. I actually had that, even though it's invisible, I had it selected. Let's make those coincident. Let's make those coincident with that 0.25 inch spacing. So we're running out of space in the bottom of our stock, but that's probably a good point for our base. Now we can see we want to reorient this. So if we take that edge and this edge and make those parallel or coincident, and then we can take this edge and this edge and have those be 2.5 apart. We can see there's still plenty of space there, so that's great. So let's do the same thing for our second base. So I'm selecting the same part. The thing with these constraints is you can sometimes give too many, and at some point you'll mess up and you'll be unclear. So by saying, you know, we match the plane of our stock to this one part and then match every other part to this part, sort of decreases the complexity of things just a little bit. So then we simply need to that edge and that edge, 0.25 apart, and then that edge. Actually, we'd like to avoid as many spacing rules as we can. Let's just make those coincident. All right, excellent. Now we can sort of think of how we could lay out everything else. And for now, I think we'll go ahead and take this and this. Apart. and this. Just have to be coincident. Perfect. All right. Coincident. All right, so I'll go ahead and finish this, but this should become clear. I simply export this as whatever shapefile would be desired for a pathfinding program for whatever particular CNC. You can, as far as I can tell, take this all the way in terms of defining toolpaths using the path portion of this. That's going to be dependent on compatibility with any particular CNC mill. But doing this is a sort of structured way to get all of our parts in the same place, on the same plane, oriented the way we think would be most useful for doing CNC milling